Howdy, Cal folks. Mr. Norman here. We're going to go over radicals. So, what's a radical? Once you draw it, you'll recognize it. This is a radical. You know it as the square root. This equals radical. The radical is the name of the symbol. It's not just the square root symbol because we can put a number in here and it'll change the operation. So the square root is opposite of square. If we put this 3 here, it's a cube root, which is the opposite of a cubing. But for what we're doing now in class, we just need to worry about the radical and think of it as a square root, because that's what it is by default. So we're going to start off with an easy one. What is the square root of 36? So you know it's 6, or at least I hope you know it's 6. If you don't, Desmos is an online calculator. It's pretty nice. So the square root of 36 equals 6. But how do we know that? Let's think about it a little bit. What does that actually mean? I think most of you will agree that the square root of 36 is 6. Can also be represented as, agree that the square root of 36, the square root of 36 can be written as 6 times 6. 6 times 6 is 36. And you can multiply it underneath the radical. So if we think about it, I'm going to use Miss Dunbar's way of explaining it. I like it a lot. The way Miss Dunbar explains it is that she says that the numbers are breaking out of jail and the radicals of jail. So they're going to partner up and try to break out of the jail. What happens is one makes it out, but the other one gets caught and they're left in solitary confinement. So that's why they turn into a 1. Well, what is the operation between two things in math when it's not given? It's multiplication. So this is 6 times the square root of 1. What's the square root of 1? Well, 1 times 1 is 1. So this is the same thing as 6 times 1, which is the same thing as 6. If you're not sure, or if you don't trust me, replay and it'll click. But you say, I don't need to know that because I know the square root of 36 is 6, or I can use my calculator. Well, what happens when you don't get a nice, pretty, even answer? Something like the square root of 125. I'll tell you now that it's not a perfect square. I'll also tell you that the answer you get from your calculator will be an approximation. It's approximately 11.2 something. But this is an irrational number, a number with the decimals that go on forever and they never repeat in any sort of pattern. In geometry class and in much math, we're going to want an exact answer. And the only way to get an exact answer with radicals is for the radical to go away, or for you to have a radical at your end result. So how do we find the square root of 125? We have to start with a factor tree. So we take 125 and we'll divide it by a number that we know goes to it. So I'm pretty sure 5 goes on that because it ends in 5. 125 divided by 5 is 25. The factors of 25 are 5 and 5. So this is a factor tree. These are our branches, and these are our leaves. We're going to go until our leaves can't get any smaller, because 5 and 1 don't matter. We just ignore them. So we have our set of 5s. So just like with the 6, we'll put our numbers inside of jail. 5 times 5 times 5. And what do we do next? They're going to group up to break out. Here's a pair. This one's left by himself. He needs a partner to get out. Well, 5 made it. 1 5 made it. 1 5 didn't. He's stuck in there. He's in solitary confinement. the other one. And the lonely 5 is still in there. It didn't have a partner, so it just comes down. Well, we can simplify this. 5 times 1 is 5. And the square root of 5 is 5. So this is our final answer. This is in simplest form. There's nothing else you can do. The square root of 5 does not simplify anymore. This is the simplest form. And this is our exact answer. The square root of 25, the square root of 125 is 5 square roots of 5. So, what happens when it's not so clean? Let's look at, I'm sorry, I forgot. You need to practice as well. Do the square root of 8. Take some time to pause. After the pause, once you're done with your attempt, I'm going to show the work so you can see if you're correct. 3, 2, 1. So we're going to make our factor tree. 8, 2, 4, 2, 2. So we have for our leaves 1, 2, 3 2s. 2 times 2 times 2. Well, they're in jail. They're going to team up to get out. You don't have a partner, so you're left behind little 2. So we have 2 square roots. 1 is left in solitary. Times 2 that got left behind. So our answer is 2 square roots of 2. 2 square roots of 2. Some of you, if you remember the term, might recognize that 8 and 125 are cubes, which means a number raised to the third power. Whenever you take the square root of a cube, you end up with the number square roots the number. Think about that. We'll circle back to it. So now let's do one that's not so clean. Let's do the square root of 24. Well, to do it, we need our factor tree. Yes, you will be quizzed on this. Yes, we have a test coming up soon. So here are the factors of 24. I have 12. I have 2. Typically, the factors, the small ones, go on the left. You can do it in either direction as long as you're consistent. 6 and 2, 3 and 2. So here are our leaves. 1, 2, 3 2s, and 1 3. Wait a minute. 3 2s. I think we did that earlier. Yes, with the square root of 8. So we know 2 square root of 2 is going to be somewhere in here. But for the sake of completeness, we'll write it out. So 1, 2, 3, 3. So we're going to group up to get out. 2 is going to bounce out. Then we have left a isolated mess. So we have 2 square roots, 1 from isolation. We have this 2 coming down. This 3 comes down. So we'll clean it up a little bit. We have 2 square roots. What is 2 times 3? 6. Oh, look at there. 2 square roots of 2. 2 square roots of 2. So we see our factor tree. Whenever you break it down, you can take the individual factors, pair them up, group them out, and you can continue. Let's go back to 36, square root of 36. let's pretend like we really don't know what's happening. Or maybe you're not pretending. Maybe you didn't remember your factors and you're like, whoa, how do we do that? So we're going to start with a factor tree. 36. We're not going to do, let's do 6 and 6. Well, if at any point in your factor tree you see the same number, you know you're going to have that number outside. So we see 6 and 6. We take the square root of 36. We know one of these is going, we know these are going to partner up. One's going to break out. So we already know we have a 6. For example, let's say instead of 36, we did 72. I know 72 is 36 times 2. And I know this is 6 times 6. I could keep going, but I don't need to. Because these are going to pair up, and this is going to be left alone. So we're going to end up with 6 square roots of 2. If you didn't follow, breathe, everything is going to be fine. You can do it the other method. So back to 36. So we're going to pretend like we didn't see it. We're going to take a smaller chunk. We have a 2, and we have an 18. Let's not do 2 and 18. Maybe you didn't see it. Most people see 3 and 12. Then we're going to have a 3 and a 4. And then, looky here. 4 is a perfect square. So we know we're going to have a 2 and a 2. We could just put a 2 outside. But if you don't see it, it's fine. So here we have 3 times 2 times 3 times 2. So we've got a pair with the same number. Boom, the 3s are going to try to hop out of prison. That means we're going to have a 3 out here. In a different color, these 2s are going to hop out of prison. Boom, we have a 2 up right here. What operation was going on here? Multiplication. What operation is going to go on the outside? Multiplication. So when these 2 hop out, we have a 2 times a 3. Got to put our jail back up. And we have not one person isolated, not one person solitary, but 2 people in solitary. But does it matter? No, those are 1s. So what's 2 times 3? 6. So the square root of 36 is 6. So whenever you have multiple pieces coming out, you just multiply them across. Whenever you have pieces left over, you multiply them on the inside. This concludes the radical portion for today. I'm going to be uploading another video with a bit more of an advanced way of seeing how to do the radicals, but you don't necessarily need it. If you have questions about this, please let me know. Contact me as always. Cal folks, out.